Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I'm going to show a movie, and I'm going to show a movie that we made about something called Mayo. Mayo is a web annotation toolkit. It is a spin-off or a successor project to SWAN. It deals with some problems that came up in SWAN. SWAN was a project we started a number of years ago to build a knowledge base of the leading scientific models of Alzheimer's disease, and that knowledge base had as its schema an ontology of scientific discourse. And the SWAN ontology is actually turned out to be of a lot of interest, and many people have done, or several groups have done integration projects with us, and it's still being used. One of the issues that came up, the biggest issue, was that we wanted to be able to create entries in this knowledge base that map back to the primary literature from which they came. So we built Mayo, which is a web annotation toolkit. How do you link elements of a knowledge base to their sources in the literature? Mayo supports both structured and unstructured annotation. It allows you to share it with other people selectively. It has a text mining interface through the Apache Clarezza project. So there's a patch in Clarezza that is in the main, or an option in Clarezza that allows you to exchange data with Mayo or any other project that uses something called the annotation ontology. The annotation ontology allows you to annotate any web document using structured or unstructured annotation, and to store that annotation separately from the document, to exchange it as RDF. Since folks from Sloan and Gordon Moore Foundation are here, I'll just mention that many things about AO are similar in spirit and in some ways in implementation to the OAC model, and we are in a series of meetings with Herbert and company at Los Alamos to integrate those models, and we expect to have a merged annotation, one common annotation model within about 6 months. So let me just show you then how you would use Mayo to annotate a web document. What we're going to look at is PubMed Central, and this is a repository of open access papers in biomedicine, and we're going to query PubMed Central to get an article of interest. Up it comes, like this one, and very interesting. We want to annotate it, so we press this little button. It's a plugin, and it opens the article in Mayo. It didn't find any existing annotation for this document in the repository. Now it's extracting the citation network for the article. There it is. That citation network can be exported in an RDF. We found that one of the references did not actually get the citation data because it didn't have the PubMed ID. So in PubMed Central, that reference is not tagged with the PubMed ID. So what we do in Mayo is we just call up, we just query and attach that information to the network, and there we go. We fixed that. That annotation, the bibliographic network is an annotation on this document, but it's also available for other users of Mayo that we authorize to use it. So now we've just gone to the version of this article that's in PubMed, which is only metadata and abstract. And we want to create the simplest kind of annotation, which is kind of a post-it note. So we'll show you more structured annotation later. Here's our post-it note to ourselves. Which antibody is this? Caitlin's smiling because this refers back to a project we did with them. Right. And now there's our Post-it note. It shows who did the annotation. Me is Paolo Ciccarese, the principal architect of this tool, who did this movie for us yesterday. The new set. So annotations can go in sets, which are just buckets for convenience. And we're calling this the notes set. It's private, but we're going to make it, or we can make it public. We're going to make it custom accessible. And here's a list of the groups that we have added to this configuration. These are folks that we collaborate with at different universities and companies. So now this can be accessed by the NIF group at UCSD and Larry Hunter's lab at University of Colorado. Now we're saving the annotations, or the Post-it note. So let's go back to look at our PubMed article. We annotated it. And now let's look at going faster than the movie here. Now let's do text mining on this article. So now we're calling the NCBO text mining service at Stanford, and it's text mined this. That's one of the reasons we made a movie, because it's actually a little slower than this. Wouldn't fit in 10 minutes. We're curating the text annotations created by the text mining service. So we're saying whether they're right, wrong, why they're too broad, too narrow, and we can actually say why. So this is of interest and use to text miners. And in fact, we have a list here of all the annotations that came up on this document. And I should say that you can use better text mining algorithms than the NCBO annotator. We implemented this web service call simply because it's very comprehensive for just about all the ontologies they have in the bioportal. So now the set, it comes up as a set of results, the NCBO annotator results. So the software agent NCBO annotator has essentially the same status as a person. It's a source of annotations, and the results are grouped into a set. That's public information, or we're making it public. If it was our own secret sauce algorithm, we could keep it private. So now, let's see, what are we going to do now? Now, we want to create a scientific claim, SWAN, using the SWAN ontology on top of this paper. And so it comes up in a tab called Discourse Element because you selected a large span of text. And now we're just changing the expression a little bit so the sentence can stand alone. Now it already knows that this sentence has been annotated with all these terms, so it allows you to pick the ones that you particularly want to associate with this claim. So we're picking protein, amyloid precursor protein, beta amyloid, and Alzheimer's disease. So now these are terms and ontologies that are associated with this scientific claim. And now we're going to associate the evidence. So we go back to the PMC article and just take a look. Now, the evidence cited there is Austin and Combs, and we'll just look that up really quickly. Next release, I hope we'll have an automated thing, so you don't actually even have to look that up. Now we've added that reference to that paper as supportive evidence. Something that we have done proof of principle on is adding data, direct data citation as evidence. And our colleagues at Dataverse are going to be providing some web services that we'll be able to access where we can hook direct data references in. So now I've got the discourse model here. It can be private, so it can be my own personal notes, and essentially it's a knowledge base. but it can also be structured, if people have heard the term nanopublications, it can also be structured as nanopublications. Here's the claim that we made. It's supportive evidence. It's got a number of terms from ontologies attached. Here it is blown up a little bit. The evidence it cites is that paper. And there it is. Right? And I am almost done. Give me just a second here. Now I'm just going to show you the annotation stream that came out of this. And very interesting. Now, if we hit export, out it comes in RDF. So, the Mayo Web Annotation Toolkit is a project of the Mass General Hospital's Mind Informatics group in collaboration with a number of other folks. And you can contact me, Tim_Clark at harvard.edu, or my colleague Paolo Ciccarese, or you can look up Domeo on the URL that you see here.